No. Now see here to derive mirror equation. So what we have done, there is a mirror. We want to find out the mirror equation. What is the formula? 1 by f is equal to 1 by v plus 1 by u, and magnification formula is h dash by f, which is equal to minus v by u. These are the two formulas which we have learned in grade 10, but only we have used the formula. Even they also give the formula. We just use the formula. Now we are going to derive it. So here, we have like this is the mirror. This is the principal axis. Object AB is the object. We are taking two rays. A ray which is parallel to the principal axis, after reflection passes through the focal point, and the second ray which has oblique incidence will reflect back with the same angle. So these two rays will meet at a point and where the image is formed. Now AB is the object and A dash B dash is the image. Now H is the size of the object, H dash is the size of the image. Here F is the focal length. Okay, and U is what? U is the object distance and V is the image distance. Will it be positive or negative? Object and image distance.
Image.
U and V, will it be positive or negative? As per the sign.
It will be negative.
Both will be negative or both will be positive? Yes.
So both will be negative.
Negative, very good. Because of the sign convention, this is minus U and this is minus V. Is that clear? And this is H and this is minus H dash. Okay. Now we are taking the right angle triangle A dash B dash F. This is A dash B dash and F. This is the right angle triangle we have taken. Now after taking this right angle triangle, we have and MPF. What is that? MP and F. This is one triangle. This is the second triangle. These two triangles we have taken. So we are taking the ratio. What is the ratio? A dash B dash by A dash B dash by PM. Okay. PM this side. This value divided by this value is equal to B dash F by FP. These are the two values. Okay, we just divided, we got the ratio. Okay, we have just taken the ratio of the sides of the triangle. Now, since PM is equal to AB, how come this is AB and this is PM? Okay, so angle APB is equal to angle A dash PB dash. Angle A, P and B is equal to what? Angle A dash P and B dash. So we are taking the ratio of that. So what it will become? B dash A dash by B dash A dash by BA equal to what? B dash P by BP. B dash P by BP. This is the value we have taken aside. And then we are taking equation 1 and 2 at the same time. Here in the place of PM, we have taken AB. Here in the place of PM, we have taken AB. Now, because B dash A dash by BA, here also we have B dash A dash by BA. So we can equate these two values, right hand side values, this right hand side with this right hand. So, but what is B dash F? B dash F can be written as B dash P minus PF. We can write in that way. So that is also already equal to this value. Now you know that object distance and image distance. What is object distance here? B dash P is the image distance and BP is the object distance and FP is the focal length. Now you substitute all the values in the formula. Then after substituting, you will get that one and simplify that. 1 by F is equal to 1 by V plus 1 by U. And magnification formula is what? H dash by H. Now take two triangles here. That is A dash B dash P one triangle, ABP is the other triangle. When we take the ratio, what did we get here? A dash B dash divided by AB is equal to B dash P by BP. So just substitute, you'll get the answers for that. Is that clear? Is it clear?
Yes, sir.
Yeah. So we'll start with refraction. Okay. So what is refraction? Refraction is, okay, bending of light past and obstructed. We said like that. Okay, sorry, that is refraction. Change in speed of light. Okay, refraction is what? Change in speed of light. Instead of saying like light bends from one, when the light is traveling from one medium to another medium, it bends. Okay, but when there is a normal incidence, there is no bending. It goes straight. So for that we have a definition: change in speed of light. Change in speed of light when it travels from one medium to another medium. Okay, when it travels from one medium to another medium. One medium to another. So that is said to be a refraction. Okay, now what happens when the light travels from rarer to denser and denser to rarer? Suppose the light is traveling from rarer to denser. The light is traveling from rarer to denser. Here the light is traveling from denser to rarer. Okay. denser to rarer medium. So what will happen when the light is traveling from rarer to denser? It bends towards the normal. It has to go straight, but it bends towards the normal like this. So this is I is the incident ray, R is the refracted ray, N is the normal, I is the angle of incidence, R is the angle of refraction, P is the point of incidence. Clear? Once again, I is the incident ray, R is the refracted ray, angle of incidence, angle of refraction, N is normal, P is the point of incidence. Like light is traveling from thing, you can think that light is traveling from air to glass. It bends towards the normal. Now, when the light is traveling from glass to air, okay, when it is traveling from glass to air. So what will happen in this situation? Suppose this is the ray of light. So what happens? It bends away from the normal. Okay, it bends away from the normal like this. It has to go like this, but it is bending away from the normal. So here I is the angle of incidence, R is the angle of refraction, N is the normal, I is the incident ray, R is the refracted ray. Clear? R is the refracted. This is the formula for. This is about refraction. Now, what are the two laws of refraction? Can anyone say? What are the two laws of refraction? What are the two laws of refraction?
Angle of incidence.
Yeah, so there are two laws. One is what? One is incident ray, refracted ray, and normal lie in the same plane. Second one is Snell's law. What does the Snell's law say? Snell's law says that mu is equal to sin I by sin R. Mu means refractive index. Mu is equal to sin I by sin R. Okay, is that clear? No, 1 second. So we have refraction. Refraction means what? Change in speed of light when it travels from one medium to another medium.
Sir, I have a doubt on this.
Yeah, tell me, sit down.
Um,
Now, so when the light is traveling from rarer to, okay, when the light is traveling from rarer to denser medium, like air to glass, it bends towards normal. And when the light is traveling from denser to rarer, it bends away from the normal. But if there is a normal incidence, nothing can happen.
This is important. Particle model of light.
No.
No, this is extra.
That is extra. So here we have loss of refraction. What is that? Incident ray, refracted ray, and normal lie in the same plane. And next one is what? Snell's law, which is equal to what? Snell's law, that is refractive index is sin I by sin R. Now we have n to 1. This notation you have to remember. Instead of writing mu also, we can write n here. Okay. So what? Instead of writing, okay. So instead of writing mu, we can also write n, okay, n12 or n21. So here we have n21 is what? Refractive index of, what is this? N21.
Refractive index of medium 2 with respect to
Second
medium
medium
1.
with respect to first medium. Refractive index of second medium with respect to first medium. Okay, with respect to first medium. This is the meaning of n21. Similarly, we write here n12. What is that?
Refractive index of first medium with respect to second medium.
Second medium. Very good. With respect to the second medium. Okay, so this is the this is what we call, we have n1 to n2. Okay, so keep that in the mind. Refractive index is independent of the angle of incidence. It does not depend upon the refractive index is independent of angle of incidence. Is independent of angle of incidence. Okay, that is the meaning. Now here, when I say n21 is greater than 1, what is the meaning? And refractive index
So,
is
incident ray is greater than refracted ray.
very good. Incident ray here is mean incident ray is greater than R. If n21 is less than 1, what is the meaning? Incident ray is less than. Okay, that is the meaning of that. Now we optical density is the ratio of speed of light of two media. Okay, same. Refractive index, another name is what? They can write like refractive index, the another name is optical density. They can also change the term in the numerical. And they can say the optical density is 1.2 something like that to confuse you. So these are some terms, okay? Like refractive index is also known as optical density. Okay. Now we'll go with the slab. Okay, glass slab. Is it clear? Any doubt in this one? So this is said to be lateral displacement. Okay. So we can write here the heading as refraction through a glass slab. Refraction through a glass slab. Refraction period glass curve. So here, this is the angle of incidence. This is incident ray. This is refracted ray. This is emergent ray. This is the angle of refraction. This is angle of refraction. This is the angle of emergence. Okay. This is the angle of. This is the angle of emergence. Okay. So, incident ray, refracted ray, emergent ray, angle of incidence, angle of refraction, E is known as angle of emergence. Okay. So now, so here, this is said to be lateral displacement or lateral shift. Okay. This is known as lateral displacement or lateral shift. Now, we will go with the three different formulas of refractive index. What are the three formulas now? Suppose. Now here, refractive index has three formulas. Number one, we have n is equal to what? N equal to sin I by sin R. This is the first formula. The second formula is n is equal to C by V. Third formula is n is equal to real depth upon apparent depth. Okay. That is known as real depth upon apparent depth. Is that clear? Real depth upon apparent. Clear? So, so here, what will happen now? In this case, the last case, what is happening now? This is let it be water. The light is traveling from air, water to air. Now this is the bulb. Now here, this is the light. So what will happen? It bends away from the normal like this. Maybe this. Okay. So what will happen? We stretch it backward and the image is formed somewhere here. Okay. So maybe this is said to be, this one is said to be real depth. And this one is said to be apparent depth. Understood? Real depth and apparent depth. Okay. So real depth and apparent depth. Is that clear? So this is how it is calculated. Sometimes they use the critical angle thing here. That I'll explain one problem that came in the board examination. Every year he's asking one question from there.
Can you explain the critical angle?
I'll explain this after this. We have critical angle, TIR is there. So that concept I will explain how they are using this concept, this real depth by apparent depth concept along with the critical angle that I will explain. Done. Okay, now so we'll go with critical angle and TIR. Is that clear? All of you. So now here we have critical angle and total internal reflection. Critical angle and total internal reflection. So what happens is when the light is traveling from denser medium to rarer medium. Okay. And the light is traveling from denser to rarer medium. Okay. So what will happen? This is the incident ray. It moves away from the normal. This is the angle of incidence, this is the angle of refraction. So if you increase the angle further, it grazes along the surface of two medium. So this is said to be angular. This is critical angle C, and this is 90 degrees. Okay. At a particular angle of incidence, here what will happen? the refracted ray grazes along the surface of two media. And the last one, if you further increase the angle, then what happens? Instead of refraction, there will be a reflection. So angle, this is said to be angle of, this is total internal reflection. Once again, when the light is traveling from denser medium to rarer medium, when the light is traveling from denser medium to rarer medium, what happens? It bends away from the normal. Now, suppose if the angle is further increased, what happens? It grazes along the surface of two media. Now, if you increase further, it will reflect back into the same medium, where the angle of incidence and angle of reflection both are equal. Clear? देखो यहाँ पे light is traveling from denser to rarer. So what happens? It bends
rarer to denser.
Denser to rarer. Here it goes in, see, look at the direction. So it bends away from the normal, right? Clear? Now, if you increase this angle, suppose let it be 30. If this is 40, what will happen? Maybe it is, suppose if it is water and air medium. So what will happen? Maybe this is 40. So it grazes along the surface of medium, like in this way. Okay. Third one, if you increase further, like from 40 to 45. So instead of no reflection, no grazing, it will reflect back into the same medium. This phenomena is known as total internal reflection. Clear? Okay.
Yes, sir.
Okay. So now here, see, we will go with relation between critical angle and TIR. Okay. So you know the definition, right? The definition of critical angle is what? The angle of incidence for which? The angle of incidence for which the angle of refraction is 90 degrees. The angle of refraction is 90 degrees. Okay. Is known as critical angle. Next one is total internal reflection, means if the angle of incidence TIR, okay, total internal reflection. Okay. If the angle of incidence is greater than critical angle, if the angle of incidence is greater than critical angle, it will reflect back into the same medium. Okay, so this phenomena is known as total internal reflection. Okay. Now here we have the formula. Here is what? Like suppose I am taking this critical angle thing. Now suppose what are the two conditions for TIR? Sir, here
So it should be from denser to rarer.
This is refraction. See, this is critical angle. This is TIR. Third one is TIR. Clear? The first one is
denser to rarer.
Yeah. Second one is critical angle. Third one is TIR. Is that clear? Is this clear, all of you? So first,
yes, sir.
Now this is N1. Let this be N1. Let this be N2. Let this be critical angle. This is 90 degrees. Okay. So here, what is the formula? N1 sine theta 1 equal to what? N2 sine theta. Okay. So we have this formula. So here N1 is equal to, I'm taking N. N2 is equal to 1. Theta 1 is equal to C. Theta 2 is equal to 90 degrees. Okay. So we have N into sine C is equal to 1 into sine 90. Sine 90 value will become equal to 1. So N into sine C will be equal to what? 1. So cross multiply, N is equal to 1 by sine C. Is that clear? N is equal to 1 by sine C. This is the formula, or this is the relation between critical angle and TIR. Okay. So we can also write here, instead of writing this, we can also write N is C is equal to what? There is one more formula. C is equal to sine inverse of 1 by N or 1 by V. Okay, so N is equal to what? 1 by sin C. That's the formula. Okay. Now, clear? Let me just stop here.
Yes.
Now, here the question is the refractive index. Okay, the refractive index of water. The refractive index of water is 4 by 3. Okay, and he's saying, asking, determine the angle of cone. Determine the angle of cone within which.
I'm coming.
अच्छा, okay, ठीक है. With which the entire outside view. Okay, entire outside view will be confined for a fish underwater. Means there is an object, something like fish inside. So like what happened is here, this is the, there's a critical angle like this. So what happened, the light is going in this way. And it forms a cone like this. Okay, this forms a cone. So this whole thing, I'm writing here, this is the angle of, this is cone now. And this is also theta. So this is the fish here, this is the object, O is the object here. So what is the formula here now? We have mu is equal to 1 by sin C, is it not? This is 90 degrees. If this is theta, this also will be theta, is it not?